Welcome back, smart mathematicians. In the diagram, BE and CD are diameters of a circle having M as the center. Chord AE is drawn. This is chord AE is drawn to cut CD at F. AE, the chord AE is perpendicular to CD. Let angle C be equal to X. This is angle C here. And then determine, giving reasons, the size of angle M1 in terms of X. So this is our angle M1 here. How can we get angle M1? Right, if you check, angle M1 is subtended by arc CE. This is arc CE. Is subtended by arc CE at the center. And then we have angle A1 subtended by the same arc CE at the circumference. So now if we get A1, we can get M1. Let's do that. This is angle A1 subtended by the arc CE at the circumference. This is angle M1 subtended by the same arc at the center of the circle. So let's find A1. This angle is given is 90 degrees. Angle C and A1 are, angle C and angle A1 are complementary angles. They add up to 90 degrees. So it means angle A1 is going to be 90 minus X, or use the angle sum in triangle. Okay, this is 90 degrees. So we can say angle X plus angle A1 plus angle, the 90 degrees, this one, which is 90 degrees here, plus 90 degrees is equal to 180 degrees, because it's what angle sum in triangle, right? And then angle A1 is equal to 180 degrees minus 90 degrees minus X. So angle A1 is equal to 90 degrees minus X. You see that? So that's angle A1 there, which is 90 degrees minus X. Let's write that. 90 degrees minus X. And then now angle M1 and angle A1 are related. These are subtended by the same arc, but the other one is subtended at the center, the other one is subtended at the circumference. So angle M1 is 2 times angle A1. Okay, so we can say therefore angle M1 is equal to 2 times 90 degrees minus X. So meaning why? There is an angle at center equals 2 times angle at circumference. Okay, done. So it means angle M1 is equal to 180 degrees minus 2x. So this angle is 180 degrees minus 2x. Okay, that's what it's supposed to do there. We're going to meet when you're doing question 10.3.